Hello everyone, welcome to my channel Coder Marco. This is the second video of upcoming 100 days TSA challenge logic building series. In this video, we are going to solve a very famous problem, that is maximum consecutive ones. Okay, first of all, let's read the problem, then after that, I will tell you how to solve it. So, in the question, we have given a binary array nums and an integer k. So we want to return the maximum number of consecutive ones in an array if we can flip at most k0. Okay. So in the question we have given an array nums which contain 1 or 0, and we also given an given given a k. So this k represented how many zeros we can convert into ones. Okay, and in and we want to return the maximum number of consecutive. Okay, so how can we solve it? So let's first of all take an example. So let's take this example: one, 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 zero, 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 one, 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 zero. Okay, and the value of k is 2. Here k represent the at most zeros we can flip in an given consecutive array. In we can flip. Okay. So first of all, we from our eyes we can see that this this is one, this is one, this is one, and we have the value of k is initially 2, so we can easily convert this 0 to 1. Okay, then we are at this index, we say that this is also 0, so we again convert this 0 to 1. Okay, so clearly we see that this sub array contain 5 consecutive ones after doing at most k flips, and here we have the value of k is 2, so here we do 2 flips. Now come here. Now I see that I can flip it, and flip it. Then I can see that this sub array will give me the consecutive 6 ones, and this also array also give me consecutive 6 ones. So here answer is 6. So are you able to find out what we want to find in the question? Okay, so how can we solve it? So in the question we need to find out the subarray which contain maximum. In the question we need to find out subarray which contain maximum consecutive ones by doing at most k flips, and here flips we can convert 0 to 1. Okay, so the first approach I have is that I'll generate all subarray. I generate all subarray, and in each subarray I count the value of 0, and if the value of 0 is less than k, then I increase my answer and update my maximum answer. So generate an to to generate an all sub array of given array, take time complexity of n square. Then after that we need to calculate count of 0, which is also taking of an time complexity. So overall time complexity here is O of n cube. Now let's see the constraint of our problem. The constraint of the our problem is the length of the our nums array is must be in between 2, 1 and 10 the power 5. And we see that our brute force approach will take O of n cube. So the time complexity is here 10 the power 15, which is very greater than 10 the power 8. So we need to optimize it. We also optimize it the solution to the 10 the power 10 o up to O of n square, but this is also greater than 10 the power 8. So how can we optimize it? So whenever you, now I will give you a thumb rule that write a thumb rule. Whenever in any question, if you have test case, the size of test case in a range in between 10 the power 4 to 10 the power 8, then always think about the solution of n complexity and of n log n complexity, because these two type of solution may work here, maybe or may work here, but in most of the cases two type of solution work in most of the question. And generally whenever this type of problem will come of sub array, we generally apply first sliding window and second prefix sum. And in most of the question, both of these sliding window and prefix sum taking of and time complexity. And we also use of and log n approach. So if we want to use of log n approach, then think about the sorting. If this question can be solved by doing sorting or not. Okay, so these two are the thumb rule. So in this question, focus on this thumb rule. This is the rule that if we have given the test case between in the range of 10 the power 4 to 10 the power 8, then think about a solution which taking the time complexity of O of n and O of n log n. And generally we know that the sliding window is taking of n complexity, and prefixum is also taking of n complexity, and we also also two pointer approach here. two pointer approach. Sliding window is the advanced version of the two pointer approach. Okay. So now come to the problem again. Just a second. Let me add another page. Okay. Also, we change the color also. Now come to this problem. So first of all, I want to tell you what is sliding window. Now generally for all the sliding window, we have an array. We apply an sliding window on array or string generally. Array, and we apply sliding window on string. In most of the cases, we apply sliding window in these two. In sliding window, we have a pointer I and j. We move this pointer j pointer up to our we move this j pointer in all cases, and we also move our I pointer when our given condition fails. Now what I want to try to say is that initially I will give you a template. In most of the cases in the sliding window problem, this template works, will work. So first of all, initially we initialize start is equals to 0 and end is equals to 0. Both the start and end of a sliding window initially are 0. Then in every counter I'll update end in every iteration, and inside it if our condition fails, then I update my start counter. Okay, so this is the basic template of the sliding window. Now come to again to our problem. Now take this example. Okay, let me add another page. So let me draw a good array so it can give you feel. Okay, let me change the color also. One, two, three, four, five, six, seven, eight. How many element we have? Three, three, six, three, nine, two, 11. Yeah, plus and okay. Also okay. Let's take this. Then fill this array triple one. Now I can change. I can one, one, one. Then we have triple zero. Okay, so zero, zero, zero. Then we have triple four times one, 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 and one, and we also have zero here. Now, what I say you that in sliding window, I'll say you that Our both start and are here now. And what is the value of k we have is 0. Now I am at this index and I also have a count variable also. This is also initially 0. Now I am at this index. I check that if this element is 0 or 1. So I see that this element is 1. So I move. Then again I'll check here that if this element is 1 or 0. So this is also 1. So I again move on and check again. Is this element is 0 or 1? So it is also 1. So I again move on and update my answer to 3. Up to this my answer is 3. Then I am at this index and check is this element 1 or not. Then I'll check that this is 0. So I'll update my counter to 1. Then again I move on to the next index and check. And initially we will have the value of k is 2 in the question. So then I again check here that if this element is 1 or 0. So this element is 0. So I again increase my count to 2. Now I am at this index. I'll check that if it is 0 or 1. So it is 0. So here my count is increased to 3 and we can flip only two zeros, but here in this sub array we flip 3 0. So I need to decrease the count to satisfy my condition. So here now I now here I update my start. So I check is it is equals to 0. So they say it is not equals to 0. So I don't decrease my count. Then move on to here. Then start is here. Then it is then it focus here and check that is it is equals to 0 or 1. So it is equals to 1. So it don't update my count and it is here. So then start again check here is it is equals to 1 or 0. So it says that it is equals to 1. So it again don't decrease the count. So it comes here. Now it check here that is it is equals to 0. So yeah, it's a yeah it is equals to 0. So here it decrease the count to again 2. Okay. Now the count is equal to 0. So our start is here, our end is here. So this is the sub array which we can get after doing this step. So now I'll again update my end. So I'll update my end. So here I'll check if it is equals to 0 or 1. So here it is equals to 1. So I'll simply move on, move on, move on. Then my end is here. So at this location I simply I move on. Then at this location I'll check that the value of my count is 3 in this sub array. So now I want to decrease the count. So I'll simply update my start and come to at this location and check that in this sub array the count of 0 is not greater than 2. So in this way we can solve this problem. Okay, so this solution would take time complexity of O of n and space complexity of O of n because we are not using any extra space in this question. Now come to the solution of. Now I'll show you the code of given problem. So now initially here I indicate to start and J indicate end. Okay. So initially I calculate the size of array 1 1 1 0 0 0. Then we have 1. Okay. Let's take this as and the value of k is 2. So okay, and we have an another variable that is answer which store the answer, and another variable count which is checking the count of zeros in sub array. If the count of zeros in sub array is greater than 2, then we decrease the count of zero in sub array while updating our start. So initially I'll check that if the count of initially j is here, and at this index I check is it is equals to 0 or 1. So it say it is equals to 1, so count is 0 initially. So now I don't go in this for loop, because this for loop update our start if our condition is fail. But our condition is that if count is not greater than k, but here the count is not greater than k, so we are not going in this loop and simply update our answer, and our answer is equals to j, which is pointing to this index j minus I plus 1, and we take maximum of this. This will give us answer. So initially j is 0 and I is also 0, and we add plus 1 because the indexing are 0 base. That's why I am doing plus 1 here. So I'll take the answer. So initially we have maximum 1 continuous 1, continuous 1 1. Okay. So now our j is here. Then I'll check again. Is this j is equals to 0? 0. So it is say that it is not equals to 0. So I'll simply move on and update my answer. So this j is equals to 1, 1 minus 0 plus 1, that is equals to 2. Now my answer is 2. Now I am again at this index. I am checking that is it equals to 1 or 0, then it say that it is equals to 0. So I'll further move on and update my answer to 3. Here I am updating my answer. Now I am at this index. Then I am check here that its count is equals to 1 or 0. So here it says that it is equals to 0. So I increase my counter to 1. But I see here that my condition is again getting failed. So I am not going in this loop. I'll simply update my answer. So this is the sub array which contain maximum 4 consecutive one, while I'll if I flip it. Then I am at this index. I see that is it is equals to 0. So yeah, it is equals to 0. So I am again update my answer. I am update my count to 2, and I again check here is is greater than 2 or not. So it say it is not greater than 2. So I'll again update my answer to 5. Now in the next turn, the count is again equal to 0, and the value of count becomes 3, which is greater than 2. So in this loop we are updating the start. So start will come here in this loop. So now the value of star will become 0 1 2 3, and the value of end is 5. Then 5 minus 3 plus 1, that is equals to 3. That is equals to 5 minus 3. Okay, 0 1 2 3 4 this index is equals to. Okay, so in this way I'll update my answer. Then after I'll updating my answer, if this condition get if this condition satisfy, then I update my answer, and in this way we can solve this problem. And this loop will taking time complexity up to of n, and in this code we are not using any extra space, so our space complexity is also of n. So so we see that if we have problem related to sub array and our test case is between 10 the power 4 to 10 the power 8, then generally think about a solution which is having time complexity of n or of n log n. And we know that the sub array generally sliding window problem generally have time complexity of n, and prefix sum also have time complexity is equals to of n, and sliding window also have time complexity equal to of n. And if we want to do of n log n solution, then we can use sorting or binary search also. So in this way you can build your intuition while seeing your constraint and seeing your problem. But first of all, try to understand the problem, then see constraint, then apply this logic. Okay, so that's that's all for today. In the next video, I'll bring in another problem on sliding window, which is asked in most of the top MNCs. So next video is next video is very important, and it is purely based on the sliding window concept. Okay, so that's all for today. Thank you everyone to watching my video.